All right, Matthew, Eli, whoever else needs this video, here we go. We are skipping a bunch of stuff. 8.3 is testing a claim about a mean. What?
Oh, I was like, what are you talking about?
Yeah, no, he's here. He's here, but he's not here. All right. 8.3, testing a claim about a mean. We're going to skip all the way to example 5 because I think you guys are getting the idea. And we're going to do example 5. We're going to do it critical value style. And we're going to do confidence interval style. Okay? So critical value is, we don't do p-value style for mean, but critical value style is labeling the bell curve. Confidence interval style is like finding where mu lives between, and you x bar minus the error and x bar plus the error and all the things, right? Okay, so we'll get to that. I might end up flooding down into this bottom part. I should have moved part 2 down, whatever. But here we go. Let's write down information that we have. I'm going to maybe put it up at the top here. Measures of body temperatures with these statistics for 12 a.m. on day 2. All right. On day 2 of my study at 12 a.m., which would be at 12 midnight. Yeah, that's an odd, like, let's wake you up and take your temperature, whatever. Okay. We had 106 people that we're taking temperature on, and the average temperature for those people was 98.2. Okay? With a standard deviation of 0.62. And we're using this to test the claim that something is happening, right? Okay? All right. Significance level of 0.05. And to test the common belief that the population mean is 98.6. Okay? That's going to do our hypotheses, H naught, H1. I'll put those up here at the top. And what variable are we using, by the way? Mu, because we're doing average, okay? And the top one is always equal to, so equal to 98.6. And the second one is which one? Not equal to. They don't say greater than, less than. They don't say anything like that, so 98.6. So when I'm going to go down here to label the bell curve.
The first one?
Yeah. When we label our bell curve, do we do the left tail, the right tail, or both sides?
Both.
Why both sides?
Because it's equal to.
Because it's equal to and not equal to. If I say your grade is not an 80, you're like, okay, I don't know if I'm below 80 or if I'm above 80. I just know it's not equal to 80, right? So if it's say equal to, not equal to, I don't know if it's above or below. So I'd label both sides, right? Now, my significance level is 5%. And if I have both tails shaded, that means 5% has to fit in here and in here. So 2.5% goes in each one. The only time I split it is if I have 2 tails. If it was left-tailed only, I would put all 5% in there, right? Right-tailed only, all 5% in there, okay? So what percent lives here in the middle guy? 95. All right, now we have to decide, because we're doing mean. We have to decide if we're going to use the T chart or the Z chart. How do I know which one to use? If n is less than or equal to 30, I use the T chart. If n is greater than 30, I use the Z chart. And here my n is 106, so I'm going to use the Z chart. So I look up on the Z chart, 95% in the bottom left corner, and it is like 1.96. 1.96 and negative 1.96. And then all I do from there is find my test statistic, which is this guy right here. It's that formula. So Z equals x bar minus mu over S over the square root of n. Okay? X bar is 98.2. Oh, so which tail am I going to be looking at specifically? I'm going to look at the low one, right? 98.2 minus 98.6 is going to be a negative number. So I'm looking, does he live in that tail or above that tail? I don't know.
So do we,
standard deviation.
So for, yeah, okay. Wait, why
10, is it 106? There you go. So we're filling out this formula. We're going to get our test value. Somebody want to do that for me?
Why does it say mu and then a low x bar?
I don't know. It just says mu in terms of x bar. So like if x bar is talking about temperature, they are saying the average temperature. Like the average based on the same units as what x bar is kind of the way that it works. So that's, yeah, I don't ever write that notation down, but yeah, mu in terms of x bar. What do you get?
Negative 6 point.
Holy moly. Okay.
What did I do?
Why did I get it?
So the problem with that formula is that you can't divide.
I put like
That's
No,
why we always
I did the bottom part separately.
You can divide if you put parentheses around the top.
I did it separately. So I did the bottom
Are you
part.
sure?
That's what I did, Colin.
Okay, never mind.
That's what I did.
Where'd you do it? I just find the top number and then I divide
Yeah,
that.
so Mallory just says the top number and then enter and then divide by this guy, which is totally
I
fine.
just do the square root on the top. Like a square root times that. Divided by
So what did
0.637.
everyone else?
Yeah.
Negative 0.0627.
Negative 0.0637. Okay, say that again. Negative 0. Point what?
0, 6.
627.
Let me try it.
0627. So 06. Because we only want 2 decimal places because we don't care about anything else. Okay. All right. Okay, so now this is Z, right? And we're already on Z's terms, right?
We forgot which answer's right.
What?
1 second. 106. Negative 0.4. Negative 6.64.
I have to like that.
Because you can't, they're doing divide.
No, I'm still getting negative 6.64.
You have to put those in parentheses on the bottom if you do that. If it like that. No, but if you divide by both of them, then it's like S times the square root of n on the bottom.
Let me see what we got going on
I
here.
got negative 6.64.
You got negative 6.64?
Yeah.
Do you have yours in there, Carter?
Yeah.
Negative 6.64. Let me see what yours says and let me see how you're typing it in and see if it's legal.
Well, I did both of them on these, and I got both answers. I got negative 6.64.
I need something.
I just did that right here.
So you get negative 6.6.
I'm mailing the ones that I'm mailing like right now.
Yeah.
And then mom just put them in my mailbox.
Sweet, that means I can finally send mine. Waiting till everyone else was certain to send them, because I didn't want to send them at the beginning of March, be the only one.
Okay. Yes,
Oh, I don't even want that.
Okay, yes. So it is negative 6.64. It is. So,
Why don't you just put the square root of n?
I'm still good.
what?
Just do it.
Put the square root of n on the top?
How are you doing? Are you like?
I don't care. If you're struggling, here's what Reese does, which is actually pretty brilliant. She does this guy, and then she flips this to the top. So here's what her formula looks like. X bar minus mu, she does that good stuff, and she multiplies by the square root of n and then divides everything by s. Do you see that? Like, that's what Reese does.
I just like put
Which is another way of doing it. What?
whatever that one number is on the top, I just do that and then press divide and I just put the full bottom.
Yeah. Just put the whole bottom in parentheses. That's totally fine. Yes, that's exactly right. Yes, and you'll get the right answer. So if you're one of those people that like to do it this way, Reese might be a rare. You're just a rare cookie. It's fine. Whatever. That's okay.
Easier.
So negative 6.64 is what you should get, right? Where does he live?
Over there.
He lives all the way over there. All the way over there. Okay? So here's the deal. If I go to my hypotheses, if he lives all the way over here, does that mean he's equal to or is he not equal to land? He's not equal to. He's all the way on the non-end side, right? So we cross this one off and we circle this one, right? So that means that the body temperature is not 98.6,
Critical value theory.
right? So we reject H naught.
Claim is false.
Does the claim go with the top?
Yeah.
Reject H naught, claim false, because the claim went with the top one. I didn't label that. Claim was the top. There you go. There's my conclusion. The body temperature is not equal to 98.6. Okay. Now, confidence interval style. Let's see if we get the same answer. Confidence interval style. So here we go. We are doing this thing. We're trying to figure out what this is. X bar was 98.2. Is that right?
98.
And then all we need to do is find what the error is, okay? Error is T or Z. I'll put T, I'll put or Z. times S over the square root of N, right? That's how we do that. That's how we did that in last chapter. T or Z. Which one is it in this case, T or Z?
T.
We used Z. What was the number that we used for Z? 1.96. That's the same number that we did over here, right? 1.96. You find it the same way, right? Okay, times S was, I don't remember what it was, 0.62 over the square root of 106. And if you do that, you get an error or something.
Bottom half of the
Yeah, yeah,
times.
yeah, yeah, yep. That's not a coincidence. This guy is the same as the formula over there. Okay, what do you get? 1.18?
No, sorry.
What do you get?
0.118. Yeah.
0.118? Oh, that's really small. But I guess it should be because it's a temperature or whatever. Okay, so if that's my error, I'm subtracting 0.118 and I am adding 0.118. So mu is living between, mu is living between like 98.318 and 98.0. 082, something like that, whatever. Yeah, whatever. If you however many decimal places you go, right? So I have this thing going on. That's my confidence interval. Now let's see if that makes our conclusion true. We are saying that the average body temperature has to be between 98.0 and 98.3. Does that mean he's equal to 98.6 if he's between 98.0 and 98.3? No, so we cross him off and we circle the bottom one. Same conclusion, right?
Wait, hang on. Can you repeat that one more?
Okay, we said that even taking into consideration the error that I have, our temperature, our body temperature has to be between 98.0 and 98.3, right? So now I look at the hypotheses and say, okay, so is mu equal to 98.6? No, 98.6 doesn't live in between that interval that I have right there.
98.6 and whether it lives in.
Yeah, where does it live, right? So it doesn't live in between there, so he's not equal to 98.6. So we cross the top one off and we circle the bottom one. So still reject H naught, claim false, right? Same thing again, right? Good, good? That's confidence interval style. They will always be consistent with each other because the formulas are the same, right? Like Ellie just said, S over the square root of N, S over the square root of N, and that like is the same. Like
The only
it's
time they'll be different is if you did it.
if you did it wrong. Yes, exactly. So you should get the same conclusion regardless. It's just doing it a different way.
Literally that.
Yeah,
Yes.
yeah, right. That's exactly what it is, right? So, yeah, that's how that works. Got it? You're just doing the same process, coming up with this. It should be the same conclusion, just a different way, right? So, homework. If you've already done these, that's great. The whole, what did we say? The whole first page? Yeah, the whole first. So 1 through 6. Yeah, 1, 2, 3, 4, 5, 6 should be all critical value style. That left column, the way that we did it the first time. 7 and 8 are the only two that you need to do confidence interval style. And maybe let's do this. Let's go through and let's figure out which chart you're using. So on number 1, just so we're clear, you use the T chart when n is less than or equal to 30. You use the Z chart when n is greater than 30. So, are you using T or Z on number 1? You're using Z. So I'm going to put Z over here. Number 2, n is 185. You use the Z. Number 3, n is 81. You use the Z. Number 4, n is 500. You use the Z. Oh my gosh, are we ever going to use T? Yes, we do on the backside. What is n for 5? 10. Oh, we use the T chart for number 5. What about number 6? Do they tell you what n is?
No, we just count them.
Yeah, you just count the numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. N is 10. So that is the T again, right? 7 is, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah. N is 15. So T again. 8 is 6. So T again. Okay, good. Confidence intervals for 7 and 8. So the whole front side you use the Z chart, the whole back side you use the T chart, basically. Got it?
Can you help me with a problem from
Sure.
3.2?
Sure. Questions?
After that, can you help me? And then
Sure.
I can help.
Okay. Are we good to go? Can I stop recording?
Yes.
Everybody's good? All right.